Okay, so the first question is related to, let me try to rephrase it, is about the format of the exam, the one that's coming and also for the rest of the quarter. And also one of the students have some question regarding one of the question from the sample midterm. So I'm actually going to just go over to the syllabus, and because it was actually from the syllabus. Wait a minute. Okay. So in the syllabus in front of us, I actually given a bunch of questions that's actually I would consider the sample midterm. You can see that, for example, let's take a look at let me actually provide some high level thing. So in ecs36b, it's important for you to understand a few concepts. And the thing is that my instructional objectives is make sure that you not just know the concept at a higher level, but you really know the detail, the implementation. I mean, it's a programming that you can actually apply this concept into programming. So therefore, when I make the exam question, they usually have two elements in each of the question. One is what is the key concept. I try to make sure you understand that. That's how I assess your learning. And the second thing is that it will have some kind of programming. So I want you to feel comfortable, not just understand something theoretically, but you actually will be confident in actually either reading a piece of code related to that concept, or you are capable of writing or modify some piece of code that's related to that concept. So that's actually throughout the whole quarter, all exam, every question must have this two element. Okay, number two, I'm not kind of professor, I'm trying to squeeze you to answer some question very fast. In fact, I kind of against that philosophy in programming. I feel you need to be careful and make the decision in your program whatever pace you like. I mean, we have to be reasonable. Of course, we're not saying that you spend 3 days to do something which you can do in 3 minutes, okay? But on the other hand, for the midterm, roughly, I feel 10 to 15 minutes is appropriate for you to handle one single question. So in other words, the midterm only have 50 minutes. So at the beginning, at the first couple midterm, I'm probably going to ask you no more than 3 questions, because if you think about each of the question, it will take about 15 minutes. Okay, so that's the format of the exam. You will get 3 questions, and later in the quarter, because you are more mature, and I would like to cover more topics in each of the exam, so I might actually add it to 5 questions, so it means 10 minutes per question. Okay, so just to let you know. So this coming Friday, you will be answering 3 questions, okay? And it's probably going to be 2 questions related to the CPP01 and 1 question related to CPP02. So CPP02 is your homework assignment number 1. And CPP01 is what we talk about person and thing. Okay, so that's the information I want to share with you. Okay, so now let's actually talk about the format of the exam. So I'm going to use forum. Is the first question, what's the question you're asking, or a different question?
I question, but like looking at what you're looking at, I actually have a question. In the code, it says CR underscore F1
Okay,
equals.
I will do that. I will take care of that. That's actually a little bit technical detail, but I will go through that
Oh,
as well.
that's
Okay.
good.
Yeah. Okay, sure. I mean, no problem.
I have other questions too, like, yeah.
Okay, sure. So let's take a look at the example question. So the first question is related to homework assignment number 1. So homework assignment number 1, what you were asked to do is given the code, my break, you're going to implement something called my heal. And my break and my heal, we kind of cover with a few other lecture. But by the way, I have to say that my heal and my break, they each have about 95 lines of code, but it's not an easy concept. Okay, let me just tell you, my heal, my break is something which I consider a advanced topic for ecs36b, because most of the instructor, they won't have time to go to the file operation. But on the other hand, I want to tell you that the learning how to do my break and my heal has a long-term impact in your programming, because whenever you deal with write the program, you have to deal with files. You have to deal with real data. And that is give you a kind of knowledge about how to handle that. So the thing is that's why question number 1 is, sorry, homework assignment 1 is very important. And this particular question, I actually asked for my ecs36b in the spring 2023. And the thing is that at the end of the homework assignment number 1, you need to see whether your program is producing the result that's expected. By the way, that capability itself is so important to programmer. The programmer, usually the confusion is not about what you want to do, is, well, is there a way you can actually you're assured or testing that the result you're getting out from your own program is what it's supposed to do. So my break, my heal in this case is actually complement to each other. So suppose you use diff, the program that you can actually compare the file before you break it and after you heal it, and are they the same? Okay, so that is actually, so this program, this question I asked last quarter in the spring 2023 is essentially saying that, wait a minute, why don't you write your own diff? So you write my break, you write my heal. Why don't you write your own program called my diff? By the way, I also attach my diff to the GitHub directory CPP 02. So you can actually see that. In fact, that piece of code is from this question. Okay, so this program, you can see that I actually give you the whole code about my diff. Okay, I give the whole code. I mean, if you look at that, this to implement something like a diff is not that you don't have to write. I shouldn't say, I should try to make sure that in programming, even 5 lines of code could be really difficult. So when you say the number of lines of code is small, doesn't mean the problem is easy. Okay, it's just saying that it's not that complicated. If you know what you're doing, you can actually accomplish a program like my diff in small amount of code. Now, by the way, this is also the other philosophy. When you try to write, when you want to train yourself to be programmer, and I want you to be brave and want to encourage you to actually be able to implement your own version of whatever tool that you're using. Okay, so that is very good. So when you're using this tool, that tool must be available from some sources. And sometimes to do this kind of exercise will sharpening your skill as a programmer is very important. Okay, so let's actually take a look at the question is asking. So this I give you a piece of code. This is called my diff. And then basically there was a one line of code I highlighted in the second page, which is, you can see that there is a lot of if then else statement. Okay, sorry, it's if statement, but with 4 logical comparison over there. Okay, I'm highlighting this code on Zoom that this piece of code is doing. Okay, so basically I asked a question related to that particular lines of code. Okay, and let me actually go over what did I ask, and so basically I explained this is the simple implementation of my div, and I just want you to focus on one line of code about that, and then I actually did not even ask you for every single component. I'm just asking you for the last component in this file, in this code. And then I want to ask the question. I asked 5 questions actually. The first question is, what is PTR byte FL? Wow, I realized that this question could take a while for me to explain, but I will try to do that. And the second question is, what is the star PTR byte F1? And then the third question is, what is PTR byte F2? And then what is star byte? And then the last one, I'm asking, what is a purpose about this code? So I kind of want the student to guess what that lines of code is, but I kind of break it down so you can actually understand piece by piece like this. By the way, Jonathan, I might start talking about pointer. Okay, all right. So that's the question is asking. By the way, I don't think this Friday I'm going to ask this kind of question. This question appear in the last exam, in the final exam of spring. So the student already refreshed their learning about the pointer, things like that. So this question is in fact is I consider could be overwhelming for the first week ecs36b student. Okay, so I mentioned yesterday I try to be gentle. Okay, I wanted to give you some time to actually refresh and build up. So don't worry about this kind of question appear this Friday. Okay, yeah. So okay, all right. So I just want to talk about this question overall a little bit, because I think the capability for you guys. By the way, this is the program the student already done homework assignment number 1. Okay, and so this piece of code I'm showing, they're actually pretty similar to homework assignment number 1. So essentially, you have to. Sorry, did I click something? Oh, did I do something? Okay, so you have to kind of understand what this code is doing. So let me actually try to address some of this, just this particular line I'm actually going to do. Okay, I will go over this code very quickly. So this code is trying to compare 2 different file, whether they're the same or not, right? So obviously, I need to have my program need to access to 2 files. That's why you can see I have a 2 line here. There are 2 pointer, file star F1, file star F2. So this 2 line I'm highlighted here basically say, hey, I'm preparing to have a variable to be able to connect me to those 2 files I'm going to compare. And I actually mentioned this at the end of the class. One of the students asked me, why did I do this null over here? That was an excellent question. It was not recorded, but I want to just tell everybody again about, you know, what is significance of this. Okay, so any pointer in C or C++, before you use it, you should always initialize the value to be null. So null is basically 0. Okay. By the way, the code, if you go to the, let me see, do I have that here?
Professor, there's a question in the chat.
Okay, let me actually see that. Thank you. Okay, so give me 1 second. I'll get to that. Your question. I want to see where I put these things there. Did I actually do that? Ah, here. Okay, if you look at the code, my break.c, by the way, I forgot whether I upload this code, but this was the question I got asked yesterday. So you see that while I'm answering the question, I actually type it in my program. That's help us to communicate more effectively. So the question is, why did I set the null for the file pointer? And I basically provide the answer. I will let you read it, okay, about why I did that. So let me actually go back to the code. So the question is, why did I use a file instead of data type? Okay, so you can see that what's the color of the word file? I just put it in. It's actually green, right? This is green, right? Okay, let me actually tell you that file, file, is actually a data type. The file is a data type. Yeah.
So it's just like int string.
Yes, yes. But the file file is like a class. It's like a struct. So in programming language like C and C++, usually we have what we call the basic data type and complex or structured data type, like object. So the difference is basic data type is just one element, integer, floating point, or even string, character. But when you have a complex data type, is like a GPS or file. It has multiple attributes. So let me just tell you why the file is a complicated data type. So file has to remember where you are in the file. When you open the file, where is the information so you can access to other. So I actually gave, when I taught ECS 150 operating system, when I taught about file system, I actually went through the detail from the abstract concept file all the way to hard disk. So there is a whole software stack, but now it became so abstract. So we only need to deal with this one single data type called file, F-I-L-E. Okay, but it's so important. That's why file system is so important, because at a higher level, how do you do that? Okay, so file is a data type. But it's interesting what I did here is that I define a file and also I put a star. I put a star there. So that means that, okay, now let's go back to Johnson, your question, that file star, we should actually read file star. So in fact, I would say the data type in this example is not file, it's a file star. Okay, file star, file is a data type, file star is also a data type. And what's that data type? That's a pointer. So it means that F1 is the object or is a variable. What's the data type? It's a pointer to a complex data structure called file. So essentially F1 is just an address. And just to let you know, in C, there is no difference between file, memory address, and array. They're actually all the same, and the long integer, whatever, 64-bit. This is why the pointer is so confusing, is because they kind of mix all this concept together, equivalent. Okay, so now I just want to let you know that whenever I say it's a pointer, it's a memory address. So essentially F1 is a variable is actually supposed to put in some kind of memory address. And that memory address represent where I'm going to store the whole complex data called file. Okay, that's what this line of code is doing. So so I said, now I go back to the null. So whenever I actually want to use a pointer, it's a really good habit for you to have is always set the pointer to be null from the beginning. Okay, why is that? Let me actually use the particular example of F1. Let's actually take a look at this F open, this line here. Let's take a look at the F open, this line. Let me actually take a look at, go to your terminal. That's why I like terminal. You can actually just say man F open. Okay, it's a man F open. You can see that. What is F open? F open is basically some of the library function. And take a look at this line, F open. This is a specification. So first, in order to use F open, you need to say include steio.h. It's a standard input output from the C. So you have to do standard io.h. And then you look at the F open. What's the return type of the F open? So F open, this is what we call function prototype. So function prototype including 3 elements. First is the name of the function. The name of the function is F open. Second is the parameter and parameter data type, means that argument. So this is basically the argument. You have to take 2 arguments when you do F open. They're both const character start. In C, that is basically a string. You have 2 string in the F open. And then the third element in the function prototype is a return type. Return type means that what is the data type is going to return when you call the F open. Okay, so this is basically when you do a man F open or any function you want to use, that this man really give you all the information. So now let me ask you again, what's the return type of F open? Anybody want to help? What's the return type? Yes, go ahead. It's a pointer to a file, right? There is a difference between what is a file as a data type or is a pointer to a file as a data type.
Would the pointer be just like an array, right? It's initializing an array, it points at the first element.
Yes, the first element of the first, we call the first byte or memory address of the whole data structures. Because good question. The file, I don't know how big that data structure. You know what? It's interesting. I want to write a program to actually test it out.
To get the return of the pointer, do we have to dereference the pointer, or is it
Later? We'll address that. Okay. So let me actually just go to the file my break. And what I'm actually going to do is I'm going to print something. Printf. I would say the first one, the size of file is equal to %d, and size of file star is equal to %d, and size of void star is equal to %d. Okay, I'm actually going to try to print how big some of the using the size of. So I'm going to do size of file, size of file star, and size of void star. Okay, let me actually see how this code will compile. Okay, it gave me a lot of warning, but that's okay. All right. So let me try to run the program. Okay, you can see that now I run the program. I mean, I just want to produce the first line. So look at the difference. The size of the whole file, the data type file, is 152 bytes. The size of file star, which is the pointer to the data structure called file, is only 8 bytes. And then size of any random pointer, void star is a generic pointer, is also 8 bytes. Why is 8 bytes? Because this computer is a 64-bit computer. 64-bit is 8 bytes. That's a memory address. Okay. So address, regardless you're pointing to void, file, integer, is always 8 bytes. Yeah.
So which file is it talking about when it says 152?
It's not a particular file. It's the data structure that's actually represent the file information. So essentially, file is a class. You can think about it's really a class. And that class basically contains a bunch of attributes such as, say, latitude, longitude. So it has a bunch of attributes. You know what? Let me actually do a Google. Let's actually look at what it really is, okay? I'm searching for struct. Here. Okay, Stack Overflow, thank you. Okay, you can see here, this was, they declare, I don't know whether this is, they usually call a struct underscore IO file, but later they rename it as a macro called file. So I think this is pretty close. So you can see that it contains like a flag, a repointer, re-end, write, a bunch of file over here. So that is, let me see, do I have? Yeah, okay, this is another one. This is probably better. Okay, this is type define struct underscore IO buff, a bunch of things, and define this as a file. So you use type def. So I'm actually curious. I want to actually add all this together. Character start 8 byte. This is 4 byte, 8 byte. It cannot be 152 bytes. So there must be different implementation. They have, why is that 152? I actually have to look at my computer to where that file is coming from. Okay. Excellent question. Okay. Okay, so this basically, let me actually tell you what I did earlier. What I did is I add this line of code, which basically says that what is the data structure file, what's the size. So when I think you asked the question is file star, it's an address. So initially I set it to null is pointing to just null. So it's unusable, by the way. At that time, it's unusable. But when they did the fopen, when you did the fopen, when the fopen returned it, let me actually use this one as fopen. Look at this fopen, right? fopen over here. So you see that I actually initialize f to be null. But after I did this fopen, the fopen will return the pointer to the file, to some 152 bytes data structure, and give the address of the first byte and assign into the pointer f. So after this line, the value of f is no longer null. So this basically represents you're ready to do something with a file, but also represent that you have fopen successfully. On the other hand, if fopen failed could be the file doesn't even exist, or you actually do not have the privilege to access that file. If fopen failed, what did I do? Okay, so if F open fail, then the value of F is actually not going to be changed, it's still null. And therefore, that's why you can see that the next line, what I did is I actually check whether the F is null or not. And then, yeah,
So that's essentially why it's good practice to first initialize the pointer.
to be null.
And so if you didn't, right, and you, in the same line that you are initializing the pointer, that you're also setting equal to the F open,
Right.
and let's say that file doesn't exist, what would happen? Would it still set it
Right.
to null, or would it set an error?
The correct implementation of F open, if the F open fail, it should always return null. Okay. There are other situations that I said to be null is that some of the environment, if you declare a pointer, if you don't set it to be null, it didn't give you null. It gives you some kind of random value. And the programmer, if a programmer is not careful and he forgot to write the code F open and directly try to use that pointer address, that could be pretty bad because that could actually causing some kind of security problem, for example. So that's why it's always a good habit to have as a C programmer, every pointer you use always set it to be null. So the other thing, have you ever heard about a runtime error called segmentation fault? This should only happen to those who have done ecs36b. This is called segmentation fault. So segmentation fault. So I'm actually going to coach a little bit about the operating system. By the way, I will cover this in more detail later when I talk about the virtual function. But essentially in C programming, in Unix environment, the first page of memory is actually unused. So you think about your memory address, the first page means address is 00000 to all the way first page is probably 1K or whatever, 4K page. That page is forbidden to use. None of the programs should use the first page of memory. You will say, well, I waste my memory. No, it's a virtual memory. The modern system is always, there is a difference between physical memory and virtual memory. So the virtual address, the first page, is never used. Why is that? It has a really important runtime error catching mechanism because anybody write the code to put a null or they forgot to actually do the right thing in open the file. They try to directly dereference a null pointer. Essentially, that's actually for you to use the first page. And that's immediately because there was a rule saying that the first page should never be used. So anybody have a code that touching the first page is immediately generating a segmentation fault. And then that's actually very important, safety, because it's better for you to fail because segmentation fault, I catch it, rather than you just put in a random address. You're actually, this is a logical error, but you're touching some important data out of the first page. So that's actually very critical design for C is that why I always put a null, because if I put a null, if the programmer make a mistake, it's going to easily generate a segmentation fault. If I don't put a null, it's unpredictable. So that is a very important lesson for you to know as a C programmer. Okay, so yeah. Hold on, let me write down the things virtual page. Okay, go ahead. Sorry. Okay, so null is actually a macro, and null is basically just 0. So just to let you know, null is actually 0. is translating to 0. And yeah, so meaning that I want to set it to be 0 address over there. So 0. Okay, yeah, go ahead.
Midterm document, it says like you have like error handling for checking the size of unsigned long. It's 8.
Right.
Is that just a good practice to put on if you're coding on like a 64-bit, because the file star and the void star would change like I guess size?
Yeah, it is. It's a bit of hack in this code, because I'm assuming that okay, what I did here is that I actually want to do efficiency. I want to actually compare 8 byte each time. The reason I want to compare 8 byte is because it's a 64-bit computer. So I kind of move the content regardless, because the file could be a file of image or text or any other format. And so I just treat then 8 byte as a unsigned long 64-bit. So that's the reason I actually want to check whether the unsigned long in the program, in the execution environment, is actually 64-bit. So for example, if you're using Raspberry Pi to do this program, you might fail, because Raspberry Pi, maybe their unsigned long is only 32-bit instead. So that's why I put there. It's a bit of hack over there. Yeah. Okay. Yeah.
To you on this line of code in that program, right here, why is what is the purpose of having the address right next to this parentheses right here?
This code. Okay. I think I'm yeah, I already you can take a look at the Zoom. Take a look at the Zoom. Is this the line? Okay, all right. So you know what? Let me try to explain this one. Okay, I tried on so let's actually first take a look. What is the F1? Okay, so I have to explain this way. So first, we have to see what's f-read. Okay, so understand f-read. You can actually get more information again. F-read. EAD. Okay, let's take a look at f-read. F-read, the function signature, the name is f-read, and then essentially it take a 4 parameter. It take 4 parameter. The parameter is basically the last parameter is what is the file. It's again, it's a pointer. It's a pointer to a file that I'm going to read it from. And then the first argument is actually void star, meaning that when you read certain amount of bytes, where you're going to put it in that address. Okay, so it's basically the reading from the fourth argument into the memory location that was actually pointing at the first argument. Okay, and in the middle, it basically say related to how much or how many bytes you're going to read. So it's essentially reading this 2 things add together. Okay, they're not add together, times together. So size, I don't want to go into the detail, but essentially the argument 2 times argument number 3 represent how many bytes you're going to read. Okay, so now let's actually go back to the code. So let's take a look at this f-read. So f1 is the pointer to the file. I already opened. Okay, so byte f1 is what I'm going to read into. So what is a byte f1 is actually declared here. It's an array of 8 byte, right? The line I just highlight is basically have 8 byte. And then I said how many byte I'm going to read is this 2 middle argument times together. So 1 times A is A. So now we understand is reading 8 byte from F1 and putting into byte underscore F1, right? So that's essentially what we're doing. Okay, so now we go back to this question. Why I did this line? Okay, that's I mean, I regret. I mean, why do I do this complicated kind of casting in C and such that I have to explain it? Okay, no, I'm just kidding. Okay, all right. So basically, let's take a look at this one. Byte F1. What is the data type of byte F1? It's an array. It's an array of character, unsigned character. Okay, so it's 8 byte, array of 8 byte. Okay, so I want to actually compare. Let's actually take a look at what I used that variable. What I did here is I'm actually trying to compare these two together, right? And these two are the dereferencing of a pointer. So I cannot dereferencing an array very easily, but I want to dereference a, well, okay, let me take it back. I don't want to compare one character by one character. This is a character. If you have a two byte F1, byte F2, I actually, if I do a character by character comparison, that's a operation. That's a time. Because I know I have a 64-bit computer, I want to compare 8 at the same time. And what's the easiest way for me to compare 8 byte? Is basically some data structure is exactly 8 bytes, such as an unsigned long. Okay, so I actually want to treat those 8 bytes together as an unsigned long. So I just compare the two unsigned long as a 64-bit one operation. So now I have to convert that address that's pointing as a pointer to unsigned character to the pointer to unsigned long. So that's what that line is doing. So this is called casting. So if you look at the byte F1 is an array. So if I add M, that represents the address of that array. And then but that is still a pointer to the unsigned character. So this part of code is called casting. I mean, by the way, this is not absolutely necessary, but it's sometimes to make the compiler feel comfortable. So casting in C is really just tell the compiler, hey, I know what I'm doing. I'm actually going to treat this particular pointer as the data type. By the way, for homework assignment number 5, you will see that in C++, casting sometimes change the address. In C, when you're casting something, nothing changed. It's just the syntax. Syntactically, I know what I'm doing. Avoid warning, avoid error. But in C++, because of the inheritance, especially with a virtual inheritance, casting sometimes messed up with a lot of memory layout. That was homework 5. Don't worry right now, okay? But you can see that I'm casting into a long pointer. So now pointer by F1 is the pointer to a long, but it's really pointing to the same location of this. So pointer by F1 is actually pointing to those 8 byte I just read, okay? Yeah.
Is it pointing to the address of those 8 bytes or just pointing directly at the content of those 8 bytes? That makes sense.
Okay, that is usually I need some kind of illustration. Let me actually use my PowerPoint, okay? Sorry, let me actually open a new presentation. Okay, after done this, I actually have to go because I have a faculty meeting coming up. So I just want to say what's the relationship. It's kind of sometimes it's interesting. Okay, so I have, let me actually, I don't want to fill up anything. Make a mistake. Okay. All right. So I have this, draw a memory box. This memory box, wait a minute, where it is. I don't like this. Okay. Shape field, no field. Okay. The first one, let me actually see the code. Byte F1. So this is first. byte F1. Okay, this is a byte. Okay, I have something which I declare. This is called byte F1, and it has the A byte, right? And this A byte, by the way, the text. This A byte is essentially the destination of the F read, right? F read that byte from the file. F1, file star F1. Okay, so that's the A byte. But this A byte has the first address. It must have an address. The first address of the byte, let me just put down something randomly, EF52, assuming that is the memory address. Okay, that is a memory address. By the way, this memory address should be more because each of this is 4 bits. So I'm going to add another 80. 1, 2, 3, 4, 2, 3, 4, 5. Yeah, 0. So this is the memory address of the first byte. Okay, so far so good. With the program is trying to do is 64-bit, but the content, let's say the content of the A byte is a long integer. So it's actually the value is 1, 2, 3. Okay, it's an integer, the content and this address. Okay, so now let's actually take a look at this particular memory address. Is called unsigned long pointer by F1. So pointer by F1, copy it. PTR byte F1. Okay, this is also a byte. Okay, because it's the address, right? But the content of this byte is going to be this. Wait a minute, I cannot copy this. Why is that? This is not a C programming problem. This is what I call a PowerPoint problem. Let me just do this, control. So the content of this 8 byte is actually this address. And the address of this is actually something else I'm going to put in here. Assuming the address of the first byte is not RR, A, B, C, D. Okay, something like that. Okay, so essentially, this one is pointer byte F1. And it's actually pointing to the other A byte. That's what this is doing, okay? So in other words, if I want to access this long variable, how do I access a long variable? I actually will say star dereferencing PTR byte F1. If I do this, this should equal to 1, 2, 3. Okay, yeah.
We're printing byte F1 also, should that also be 1, 2, 3?
If you print by F1, you might not likely to get 1, 2, 3 because it's interpreted by F1 as an array of character. So it will only print like whatever byte, like the first character or second character. Yeah, so that's why we do this casting. So it will interpret the 8 byte together.
And that's because an array is a pointer to the first.
Right. Yeah, that's right. That's correct. Okay. That hopefully solves some of your issue. But I actually have not office hour, a faculty meeting I was asked to do, so I cannot do the rest. Ming Chen, I'm sorry I didn't have a chance to cover the download and the make file,
Oh, it's okay.
yeah, just ask me after class tomorrow, okay? And I
Okay,
will-
thank you.
all right. All right, thank you, everybody, and see you tomorrow.
Thank you, Professor.
You're welcome.